So, hello everyone, good day. So, welcome back to our lecture video presentation. In this video, this will be the continuation of the part 2 of our lesson number 2, which is about numbers and measurements. Without further ado, let's get started. So today, we'll be discussing more on the parts of measurements, especially in terms of units. Units, these are can be classified as base unit and derived unit. So first is that we will discuss base unit. Base unit, it designates the type of quantity being measured. Usually, base units na ginagamit nato is based on SI units. So SI, this is from French System International, and this is the base units that are usually used for science and in measurement. So as you can see here in table 1.2, we have 7 base unit or base quantities. So first is that we have length, and then the name of its unit and its corresponding symbol. So for length, we have meter, and the symbol is M. For mass, we have kilogram, the symbol is kg, and then time, second, or S. Electrical current is ampere, or capital A. Temperature, Kelvin, capital K. And then the amount of substance, which is the name of the unit is mole, and the symbol is MOL. And then lastly is for luminous intensity, where the name of the unit is candela, and the symbol is CD. So these are the basic SI base units that we are usually using in our measurements. So also we have this term called derived units. So these are units that comprise combination with these base units. And they are termed derived units. So usually these quantities are those that are expressed in terms of combinations of base units by mathematical means. So usually they are on multiplication and division, but not in terms of addition and subtraction or any other sign, just combination in terms of multiplication and division. So example for this is that we have the unit joules. So for joules, this is equal to this is also equal to 1 kilogram square meter per second squared. So meaning there's a combination of the unit weight or mass, and then multiplied it by the squared of length, and then i-divide siya for the squared of time. So this is an example of derived units. So again, derived units, these are the results from mathematical combination of SI base units. And then the calculations involving derived units follow the same principle of other unit conversion calculation. So here we have, since I discussed already some examples for base quantity, we have here other examples for derived quantities. So for volume, this is equal to the cube of the length. So the unit is in meter cube. And then for density, this is equal to the combination of unit of mass and divide by the length, the cubic unit for length. And then velocity, which denotes as small v, it's equal to meters per second, so length over time. For force, this is equal to Newton. So Newton, there are many units that corresponds to Newton. So later we'll be familiarized with that. And then acceleration also, which denotes as small a, it's equal to meters per second squared. So here, volume, it's an example of a derived unit. So it is defined as the length cube and has an SI derived unit of cubic meters or meter cube. But usually in our calculation, we apply different units for volume. So this conversion, you should memorize this in order for you to proceed in the calculations of converting 1 unit of volume to another. So here we have 1 liter, which is equal also to 1 decimeter cube. And then for 1,000 liter, we have it's equal to 1 m cube. And then for 1 ml, it's equal to 1 centimeter cube. And then for 1,000 ml, we have 1 liter. So for example, if you were asked to calculate, to convert liters to meter cube, so you just need to use this conversion. And then if you were asked to calculate ml to cm cube, you will also use this conversion. So you should be familiarized with this one because it's very, very applicable in solving volume-related problems. Also, another example of derived unit is density. So this is defined as the mass per unit volume of a certain object. So usually, density it's a physical property of a certain substance. So usually, it doesn't matter if how much the quantity of the substance is, as long as the mass and the volume can vary, but the ratio or ang density nila will always be constant for a certain substance. So here in this table, we have different densities of some substance at 25 degrees Celsius. So we have here air, ethanol, water, mercury, table salt, iron, gold, and osmium, and then its corresponding density at 25 degrees Celsius. And this is in terms of the unit grams per cubic centimeter. So this is the formula for density. Where rho, this is rho, the symbol for density. And then rho is the density, m is the mass, and b, the capital B, is the volume. So generally, the unit of mass is the gram, and then the unit of the volume is the ml for liquids, cm cube or cubic centimeter for solids, and liters for gases. And then we also have the concept of specific gravity of a certain substance. So this is equal to the density of the substance at a certain temperature over the density of water. So we go now to the SI prefixes. So here, so this is a prefix that we use based on the international system also. So this prefix, SI prefix, tells us that a larger or smaller unit is indicated in this way. It is important to realize that the prefix is only a power of 10. So as you can see here, prefixes are based on multiples of 10. So this SI prefixes is used to simplify numbers that are usually very big, very big quantity of numbers or measurements, and also very small quantities of measurements. So here, it's very important that you familiarize all of this. Its factor, its name, its symbol, because you could easily separate them when you cancel different units, and then you connect the prefix to other units in that calculation. So later we will demonstrate that in our further examples. Here, those prefixes are based on this in this 3 divisions. So we have macro scale. So here in macro scale, we could measure our quantities in a larger quantities or larger measurements. So usually makita natin sila. We could see them in our naked eye, so we could measure them easily. For microscale, those are things that are quite not visible on our eyes, and then we will use different types of systems or devices in order for you to measure this. And then usually the ranges of this of the unit in the using SI prefixes is very small. Then we have also nanoscale, which is much more smaller than microscale. So example for this are the if you measure virus, protein, molecule, water molecule, or even the atom, which is very, very small. So yes, this is the range of different types of the SI prefixes that you will be using. So yes, that's it. Now we go to temperature. So temperature is measured using Fahrenheit, Celsius, and Kelvin, or the absolute temperature scale. So what can you see here in the picture is 3 different thermometers in 3 different measurements. So we have Kelvin, Celsius, and Fahrenheit. So Celsius is currently a derived unit for temperature in the SI system. So Kelvin, as we know, this is the base unit. And then the abbreviation of Celsius or degree Celsius and the size of 1 Celsius degree is the same as 1 Kelvin. So usually the conversion of the readings from Celsius to Kelvin is simple, since the two scales are simply offset by 273.15 Kelvin. So ang change sa isa ka Kelvin is equal to the change of 1 degree Celsius. So here, as you can see, this reading here is the freezing point of water. So for Kelvin, the freezing point of water is 273 Kelvin, which is in Celsius 0 degrees Celsius, and then in Fahrenheit, which is 32 degrees Fahrenheit. For the room temperature, we know that it's 25 degrees Celsius here in Celsius scale. So you just add 273 in this one in order for you to convert it to 298 Kelvin. And then also, this is the corresponding value in terms of Fahrenheit. For body temperature, we know it's 37 degrees Celsius. So you just add 273 again. So 310 Kelvin siya in the body temperature in terms of Kelvin. And then it's 98.6 degrees Fahrenheit for Fahrenheit readings. And then also for the boiling point of water, we know it's 100 degrees Celsius. The water will boil at this temperature. So you add here 273 to find the boiling point of water in terms of Kelvin scale. And also the value for Fahrenheit, it's equal to 212 degrees Fahrenheit. So now we talk about the temperature scale conversion. So the following equation is used to convert degrees Celsius to degrees Fahrenheit. So you just need to familiarize this conversion. So if you are given a temperature reading in degrees Celsius, so what you need to do is multiply it by 9/5 plus 32. So you could get now the temperature in terms of degrees Fahrenheit. Also, the following equation is used to convert degrees Celsius. As I've said, like here, you just add 273.15 degrees Celsius. So you could get now the unit for Kelvin. Then if you are you're given the unit in terms of Kelvin and you want the unit in degrees Celsius, so you just need to subtract 273.15. So remember that 0 degrees Celsius is equal to 273.15. So quick note, the conversion of Fahrenheit to Celsius is usually in terms of 9/5 or 1/8. So as I've mentioned earlier, the change in Kelvin is equal to the change in degree Celsius. This means that even though they have different units, uh, but they have the same or equal magnitude. So 1 degree Celsius is equivalent to 1 Kelvin. So for degrees Celsius to degrees Fahrenheit, this 9/5 or 1.8 change of degrees Fahrenheit is equal to 1 degree Celsius change because they also have units of equal magnitude. Again, so we are given here an example problem. So we are asked to convert a reading from degrees Fahrenheit, which is 102.5 degrees Fahrenheit, convert it to degrees Celsius and Kelvin. So what we need to do here is to take into account the unit that it needs to be convert, where it needs to be convert, and then the formula that we will be using for the conversion. So we know that degrees Fahrenheit is equal to is equal to degrees Celsius multiplied by 9/5 plus 32. So this is the way that we will be using if we are given the Celsius and then we want it the conversion to degrees Fahrenheit. But if we want it to go to degrees Celsius and then we are given the degrees Fahrenheit, we just need to subtract it by 32 and then multiply it again by 5/9. So we could get here the units, the readings into degrees Celsius. That's what the thing that we need to do here for letter A. So 102.5 degrees Fahrenheit minus 32 times 5/9. So we could get here a reading in terms of degrees Celsius. Just need to compute this. So we got a reading of 39.70. So 39. That's 39.70 degrees Celsius. So for letter B, we are also asked to calculate this reading in terms of Fahrenheit. So what we need to do is we just add 273 in this reading because to convert degree Celsius readings to Kelvin, we just need to add 273.15. So 39.17 plus 273.15. So the answer would be it's 312.3. So this is our reading in terms of Kelvin. So I have an exercise for you. So do this in your own. So you convert negative 78 degrees Celsius in terms of Kelvin and degrees Fahrenheit. So let's continue. So we have here problems involving in solving chemistry, which involves ratio. So example for this is the mass density. So I've already introduced density in the past slide. So it's equal to the ratio of the object's mass to its volume. And then this mass density or density is temperature and compound specific, meaning it is dependent, or I mean it's specific to any compound or substance, and then it differs in different temperature that this substance is in. So they have a different density in 25 degrees Celsius, in 100 degrees Celsius, and something like that. So this mass density involving ratio, this allows conversion between mass and volume. So for example here is that if you're given a volume and then you want it to convert uh, into mass, so you just need to use its density. So here we have a liter. If you have liter, so you need to convert it into grams, and then you have a density reading of in terms of grams per ml. So what you need to do is to convert this liter into ml by using conversion factor. So ma-cancel ang liter, also the ml. So the multiplied it now to its mass density, and then you could get the mass of the substance. So pwede put the other way around. If you're given the grams or the mass, then you want to calculate the volume. So you just also need to divide it by the mass density. So the units of measurement can be used to determine how to write the appropriate ratio by cancelling out, and this process is called dimensional analysis or factor label method. So usually dimensional analysis or factor label method, this is a method in calculation in which one carries along the units of quantity. So this is a method that uses the fact that any number or expressions can be multiplied by 1 without changing its value. So in this type of analysis, you must ask 3 of these questions. So you were asked what data are given, what quantity do you need, and then what conversion factors are available to take us from what are given to what we need. So that's the basic concept. So in general, to apply dimensional analysis, we use the relationship of this. So here we have the given quantity. We have given quantity. Then we multiplied it by the conversion factor. Then we could get it. We could go or could obtain our value in its desired quantity. And the units cancel as follows. So this is the flow of this process in dimensional analysis. So simple technique for you to easily do this is that it requires a little memorization of these conversion factors that you're going to use, and then you just need to take into account that this is based on the relationship between different units, and it's expressed in the same physical quantity. So yes. For example, if you wish to convert 20 yards to feet, so what you need to do is to know the conversion factor between feet and yard, or yard to feet. So for 1 yard, it's equal to 3 feet, and then for it's also you could also use this 1 yard per 3 feet. So it depends on what unit you want it to be cancelled out. You just need to put the unit on the denominator for it to be cancelled. So here you're given 20 yards to feet, and then so you need this unit, diba? So this is the one that you need to put in the numerator so that it will not be cancelled out. So 20 yards multiplied it by 3 feet per 1 yard, it's equal to 60 feet. So you already convert this unit into your desired unit, which is into feet. So these are the most common conversion, a very simple lang na conversion between the length, mass, and volume in US and metric units. So for length, if you want to convert something that is in inch to cm, you use this conversion for yard and meter, for miles to kilometer, and then miles to feet. And then for mass, we have pounds, this is 1 pound. Then you want to convert it into grams, you just multiply it by 454. Same for 1 pound to ounce, and then 1 ounce to grams. For volume, is that this value here, you could this unit here, you could multiply it by 0.9464 liter, and then 1 gallon is also equal of this. So these are just simple relationships among US and metric units for conversion factors that we need to use in the calculations. So example problem number 2 is that a person's average daily intake of glucose, which is a form of sugar, is 0.083 pounds. It's in terms of pounds. So what is the mass in milligrams? So this is the conversion. What we need to do is to know what quantity that we are given. So we are given 0.0833 pounds. And then we want it to convert it into milligrams, but we are given the conversion factor of pounds to grams. So we have to go further in our calculations. So what we need to do is that we need to write the given. Then we use the conversion factor that we are given. So for 1 pound, we have 453.6 grams. And then in terms of milligrams, we know that 1 gram is equal to 1,000 milligrams. So we just need to multiply it. So that's milligram. Then the units will be cancelled. Then calculating for the result. So we could get an answer of 37,784.88 milligrams. So we need to convert that into 3 significant figures because we are only given here 3 significant figures. So it's also equal to 3.78 times 10 to the 4 milligram. So this is the final answer. It's very easy to calculate in this type of problems, as long as you know the correct conversion factor that you need to use in the process itself. For example, problem number 3, how many milligrams of sodium hydrogen carbonate are in a 55.0 ml of solution that contains 3.48 grams per liter of sodium hydrogen carbonate? So let's take into account what are given and what is needed in this problem. So we are asked how many milligrams, so it's mass. And then we are given the volume, which is in 55.0 ml. Sorry. Then we are also given the density because the unit here is in mass per volume. So it's 3.48 grams per liter. So what we need to do is to get the mass. We know that density is equals to mass over volume, and we are given the density and mass. What we need to do is to get the mass, we multiply the density and the volume. So density here, we have 3.48 grams per liter, but we will convert this into grams per milligrams per liter, so that our unit will be consistent to the value. So we need to convert the liters here into ml by multiplying it by 1 liter is equal to 1,000 ml. So our unit will be grams per ml na dayon. Then we multiplied it by the volume, which is 55.0 ml. For you to get the mass in grams. By doing so, here. So the units later will be cancelled out, and then also the ml. So you had an answer of 0.1914 grams. But we are asked the mass to be in milligrams, so we need to convert it into milligrams. So here we have 1 gram, we have 1,000 milligrams. Just need to multiply it by 1,000. So the final answer is 191.4 milligrams. So this is the final answer. So it's in 3 significant figures, so we need to convert this. So it's equal to 1.91 times 10 to the power of 5 milligrams. This in terms of 3 significant figures. So this is a problem using mass density conversion from density to mass. So for our practice problems, I'll just leave this to you to work on. So I have 2 problems here. So convert the following temperatures to Kelvin. Here we are given 113 degrees Celsius, which is the melting point of sulfur, 37 degrees Celsius also, which is in the normal body temperature, and then 357 degrees Celsius, which is the boiling point of mercury. So just convert these temperatures to Kelvin. And then carry out also these following conversions: 185 nanometers to meters, 4.5 billion years, roughly the age of Earth to seconds, and use the assumption that there are 365 days in a year. And then also convert 71.2 cubic centimeter to cubic meter, and then 88.6 cubic meter to liters. So okay, that ends the topic that we had in measurements and numbers and measurements. So I just want to thank you for watching this video, also the first one, and I hope that you learned a lot in this lecture video presentations. And if you want to reach out or send your answers, so just email me in my personal email, and then I hope to reach out also for you and then reply in your emails. So again, thank you very much, and I hope to see you on the next lesson. Thank you.